Right, in this video, we'll be going over the steps of how to draw Lewis dot structures. So our first step is to determine the central atom. So let's say, for example, you have H2O water. Which atom will be going in the middle, hydrogen or oxygen? So to determine that, there's two different methods. So one, you can look at the periodic table and see which atom has the greatest amount of bonds. So let's just start with from left to right. So hydrogen has 1, 2, 3, 4, and then 3, 2, 1. So group 1 has 1 bonds, and then group 2 atoms has 2 bonds. So for hydrogen there's 1 bond, and for oxygen there's 2 bonds. So because you know oxygen has the greater amount of bonds, it will be the atom in the middle. And what if you have SO3, so 2 atoms that are in the same group? So in that case, you just have to look at the atom with the least amount of numbers. So oxygen has 3 atoms, and then there's only 1 of sulfur. So in that case, sulfur will be in the middle. Alright, so our step 2 is to determine the total amount of valence electrons for molecules. So for example, if we have CO2, how many valence electrons do each of these atoms have? So to determine that, we're going to go back to our periodic table and group them from left to right again. So in this case, determine the amount of valence electrons, not the bonds. So you'll count 1, 2, 3, 4, 5, 6, 7, 8. And for He, helium, there is an exception. Instead, this will be 2. Alright, so in this case, so this is the amount of valence electrons each group has. So for C, there's 4. So if you go back down here, so there's 4 times 1, because there's only 1 of carbon, which is just 4. And then if you go back to the period to determine for oxygen, oxygen has 6 valence electrons. So then you'll go 6 times 2, since there's 2 oxygen, which is 12. And then if you add them up total, that'll be 16. Alright, so once you've determined the total amount of valence electrons, you can draw a single bond with each atom. We know C is going to be in the middle, so we'll draw O here and letter O here. Again, this is for CO2. Right, and just draw a single bond with each atom. Now, just to keep in mind, a single bond has 2 valence electrons in them. Right, and now we're going to move on to step 4. So step 4 is to draw the remaining valence electrons. So if you look at oxygen, so actually if you look over here at the total valence electrons, we had 16 at first, but then once we draw our single bonds, this will be 4. And now we have 12 remaining valence electrons. So we just have to draw them on the oxygen. So 1, 2, 6, 7, 8, 9, 10, 11, 12. And there you go. And so for step 5, you have to complete the octet of the central atom if there are remaining electrons. So what this basically means is the octet rule is basically where the central atom has the tendency to have 8 valence electrons in total. So if you look at carbon, it only has 4 valence electrons, and since there are remaining electrons, we can draw them in with another bond. So for example, we're going to be moving this here to the middle, and this as well. So instead, we're going to have now is 2 bonds with 4 valence electrons on the oxygen. And that's how you draw CO2. Alright, so for our next example, we're going to be drawing the Lewis dot structure for sulfate, which in this case is an ion since there's a 2 minus over here. Alright, so our first step is to calculate the total amount of valence electrons for sulfur and oxygen. We can do that by looking back at our periodic table again. We see that sulfur and oxygen, they both have 6 valence electrons. Right, so for sulfur, it's going to be just 6 times 1, which is just 6. And for oxygen, it's going to be 6 times 4. But you're also going to add the 2 because because it's an ion right here. So if there's a minus 2, you need to add 2. So in this case, this will become 26. When you plus these, this becomes 32 valence electrons in total. Right, so your next step is to draw the single bonds with each of the atoms. So you know sulfur is going to be in the middle because there's only one of them. So right, and if you count them all the bonding electrons, 2, 4, 6, 8, you've used 8 in total. So if you subtract this by 8, you get 24 valence electrons. So you'll draw that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so that's 24 valence electrons in total. However, because this is an ion, the diagram is not fully done yet. If you look at the octet rule, because sulfur comes after period 2, it can have more than 8 valence electrons. Right, so now we're going to look at our formal charges for sulfate. So for sulfur, the valence electrons is 6. Same for oxygen. And for bonding electrons, it's 2, 4, 6, 8. It's going to be 8 divided by 2. And for oxygen, it's going to be 2 divided by 2. For non-bonding electrons, there is 0 for sulfur. However, for oxygen, there is 1, 2, 3, 4, 5, 6. Now, to find the total ion charge, you're just going to subtract all of these. So for sulfur, it's going to be 6 minus 4, which is a positive 2. And for oxygen, it's just going to be 6 minus 1 minus 6, which is a minus 1. Alright, so in this case, sulfur is going to be plus 2, and oxygen is going to be minus 1. Now for formal charges, you need to make sure that the total ion charge is as close to as 0 as possible. So you see plus 2 for sulfur here. We're going to try to make that as close to 0 as possible. In order to do that, we're going to create another line bond with oxygen from both sides. So we'll do that right here. Alright, so we're just going to erase one of these bonds here. Add another line and add another line bond. So now we're going to calculate all our formal charges again. Alright, so for sulfur it's again 6, 6, 6. Bonding electrons is 2, 4, 6, 8, 10, 12. So it's 12 divided by 2. For oxygen, so there's oxygen 1 and oxygen 2 because these two oxygens have 6 valence electrons. So this will be oxygen 1. And these two oxygen only have 4 electrons, so this will be oxygen 2. Right, so for oxygen 1, so bonding electrons, there is only 2. So 2 divided by 2. For oxygen 2, there's 2, 4. So 4 divided by 2. And non-bonding electrons, for sulfur, there's none, so it's again 0. For oxygen 1, there's 2, 4, 6. For oxygen 2, there's 2 and a 4. Now you just have to subtract all these. So this will be 6 minus 0, which is just 0. And 6 minus 1 minus 6, which is negative 1. And then 6 minus 2 minus 4, which is just 0. Okay, so now that you have this will be, the only charges here will be for oxygen 1, so negative 1 and negative 1 right here. Right, and because this is an ion, one thing you need to make sure to do is to put the brackets around the diagram. So if you have this right here, this right here, and to make sure you write down 2 minus because you were drawing SO4 2 minus. Right. Thank you for watching. If you found this video helpful, please like and subscribe for more.